Hello and welcome to this video dedicated to the sketch environment on IronCAD. In this video, I'm about to create a curved part and I'm going to make it parametric. Also, in order for the curved part to react correctly when changing parameters, I'm going to use sketch constraints. As you can see on the drawing, the parametric part depends on three parameters: an angle, a radius, and a board width. To start, drop a panel from the Aukema Tools catalog, choose Horizontal Orientation. Click on the padlocks to block the length and width of the part. I'll explain why I block dimensions later in this video. I then pass a parameter to use a section which will allow me to redesign the part face, then validate using the green button. Scroll down the tree structure on the scene until you reach the panel section and then right-click Edit Section. You now enter the sketch environment. On the shape, we can see small signs. These are geometric constraints. In the ribbon on the right, you will find various geometric constraints that you can place on your drawing. By default, IronCAD can suggest or activate automatic geometric constraints. To activate them, right-click on the sketch and select Constraints. Then check the ones that you want to activate automatically. As a reminder, the basic behavior of IronCAD is non-parametric. For example, if I pull on a line, we can see it is moving. If I pull on a corner of the rectangle, we can see that it will lose its perpendicularity and the shape will therefore no longer be a rectangle. To avoid this, we will use geometric constraints. On each corner, we can see small signs suggesting a constraint. On the rectangle and at the corners, the suggested constraint is a perpendicularity constraint. To activate them, double-click on them. They will take on the red color to show that they are active. After activating the constraints on the four corners, when I pull on one of the corners, we can see that the rectangle will now remain rectangular. Something else, as you can see, my rectangle no longer touches the x-axis in red and the y-axis in green. It will always be important to somehow reference these two axes or the origin point of the sketch in order to have a well-defined sketch. I will therefore use the collinear constraint to replace the lines on the axis. The collinear constraint icon shows that these lines are well locked on the axis. In addition, they have turned green, which indicates that they are well defined. Now, let's place a smart dimension to fill in the length and width. By default, these smart dimensions are locked. Once placed, we can see that the shape is completely green, and on the left in the properties, we can see that the sketch is well defined. Let's start the curved part. I place a 3-point arc of a circle, then two straight lines, and I deliberately choose not to connect the drawn element in order to be able to use constraints and therefore to define the geometry well. To connect the different elements, I click on the coincident constraint, then on different points. We can see that the points meet and that the coincidence constraint icon appears. Once the shape is obtained, I place a first smart dimension for the radius and then the second for the angle. Small tip: in the sketch environment, you have the possibility of passing your layout in construction lines. Use these construction lines to build the desired shape. So I select all my layout, then on the left I check the box Use as Construction. We can see that the lines are now dotted. The rectangle on the left represents the rectangular dimensions of the panel required for your curved part. Understand that in the end your curved part will be inscribed in this rectangle. The dimensions of the rectangle will therefore be defined by the angle of the radius of the part. It will therefore be necessary to unlock the smart dimensions of the rectangle. To do this, select the smart dimensions, right-click, unlock. They will take on the color blue and will therefore be there for informational purposes. Now, let's trace the shape of the curved part. I start by drawing a 3-point arc, then use the offset tool to create a second circular arc, and I make sure to check the constraint box and fill in the width of the part. I then use a coincidence constraint to connect the corners of the construction line shape to the arcs I just created. In order to give them the right radius, I use a concentric constraint. We can see that the arcs are placed correctly according to the radius of the form in the construction line. I still have to create two lines and then connect them using the coincidence constraint. The shape now created is fully constrained to the construction geometry. I can now drag the path inside the rectangle to inscribe the part in the rectangle. Then I use the coincidence constraint to match the lines of the rectangle. I am trying to have at least one point on the x-axis and one point on the y-axis and connect all the lines from the rectangles to the arch shape. And to finish at the level of the curve, I use the tangent constraint so that the line of the rectangle always corresponds to the maximum point of the curve. Once fully constrained, my sketch took on the color green, and on the left we can see it is well defined. Click on Finish to validate the sketch. Back to the 3D scene, I select the panel, then right-click Parametric. In the Parameters table, we find different smart dimensions created in the sketch. I find the two dimensions of length, width, and I will copy in the H and L of the part in order to enter these dimensions in the properties of the Alchemap panel. Test your model, modify the radius, angle and width of the part, click on Apply, then OK. By clicking in the 3D structure, we can see that at panel level, the sizebox dimension does not correspond to the part. To adjust this, you will have to enter the corresponding parameters in the properties of the panel's IntelliShape. I open the properties of the panel, Sizebox tab, I check to display the formulas, then fill in the correct parameters H, L and S. I validate and we can see that now the sizebox corresponds to the part. Your part is now complete. The target will therefore to obtain a well-defined sketch using smart dimensions and constraints. A well-defined sketch will react correctly when changing parameters. To give you ideas, here is an example of using a parametric and constraint sketch with this curved desk comprising two curved panels. When I change the settings of the desk, it can be seen that all the items will follow correctly. The model has been defined and constrained, and it does not generate errors.